share my screen. Fine. So we have also made a group, right? So the WhatsApp group, the idea is, sometimes you want to convey something, or something urgent you want to say, and you want to pass the information that is useful for everybody. And it is for me also. Basically, I wanted you to join the group for my comfort, basically. So if I want to pass an information immediately and the Teams is not available, so I can put it in the group. So please join the group. So still, some 69 or only those many participants are there. So there are totally 75 students in the class. So tell everyone to join. This is for, we will kind of use it for, official purpose. In the sense, if I want to pass some information, or you want to ask a doubt which is helpful for everybody, so you can put your concern in that group. Okay. So the first thing that I would like to discuss will be the syllabus, obviously, and the lecture plan. Okay, so lecture plan I have made in detail. So it is mostly what we followed the last year. Okay, but there are few changes based on this year, because we have a different evaluation pattern. So accordingly, the portion of what will be the portion of quiz, what will be the portion of periodical test, and end semester, everything I have mentioned in the course plan. I will upload this in Teams today. Okay, so I will discuss that. Let's get started, and then I will discuss that also, the lecture plan and evaluation pattern. I will be discussing with you in today's class, and I will also upload that in in Teams file section. All right. We will start with the basics of what exactly we mean by algorithm analysis. Okay. Yes, definitely. I will assume that you already understand those stuff. Okay. So we will do it not in a very slow fashion, but yes, we will cover. We will touch upon everything, because I know you wanted a revision, right? That's why you have joined this course. Okay. So we will do everything. Okay. So this is the course. Okay. So which slide I have to go to lecture 1. Okay. Yeah. So lectures are well planned, and accordingly, I have put the lecture plan in the lecture plan that I am going to provide. I have even put the name of the lecture in that lecture plan. Okay. So the name of the course is Advanced Algorithm and Analysis 15 CSE 331. Okay, and so I already discussed when I gave the introduction also that the two courses are the prerequisites of this course. One is data structures and algorithms. So you must have studied all kind of data structures, starting from stack, queue, starting from, let us say, array, stack, queue, linked list, right? And then you would have studied various kind of trees, right? Binary tree, and maybe, other kind of tree, and then what are their usage, what is a binary search tree. You would have studied all those things along with the heap data structure. Okay, so this is, so there also, when you would have discussed searching or sorting using arrays, right, or using linked lists, you would have analyzed, the algorithm, right? So these things are the prerequisite for your this course, Advanced Algorithm and Analysis. And then you would have studied design and analysis of algorithm also. So if this course would have focused, 15 CSE 211, if this course would have focused for your, how do you design and how do you analyze the algorithm. But definitely when you talk about algorithm, you study it with the help of examples, right? So you would have already studied various kind of examples. Okay, so then what is remaining in this course? Okay, something more deep. Okay, so maybe some more new kind of problems, or the problems that you have already studied. Okay, so let us discuss, if there are various algorithm design techniques, then Can I solve the same problem by various algorithm design techniques? Those kind of stuff will be there, right? For example, you have the technique, you have greedy algorithm, right? So the greedy kind of techniques are there. Then you have divide and conquer technique, and you also have dynamic programming, right? Divide and conquer, dynamic programming, greedy algorithm. Okay, so we must understand the difference between them. Okay, not only as what is the definition. So when I say greedy, it should come to my mind that okay, greedy approaches will follow a specific pattern. Okay, when I talk about divide and conquer, so okay, so the approach by which I solve a problem using divide and conquer, it will have a specific design technique. It should strike to my mind. Similarly, how how dynamic programming is different than divide and conquer. Okay, then if a problem is given to me, how should I solve it? Right? Is it always good to solve it using dynamic programming because I know dynamic programming? No. Right? So is it always good to solve a problem using divide and conquer? No, certainly no. Okay, so why we know that greedy techniques are there, and greedy techniques are something like they do not they see what is the immediate gain basically. That's why their name is also greedy technique. They don't analyze the complete thing. What is the next gain? What is the next best? That is what they pick up, right? You would have studied these techniques, right? So as the name indicates, greedy techniques are like, what is the best? What is the next best that I will pick? But probably that the best that I'm going to pick up now is ultimately not going to help me. It is not going to give me the best overall solution, right? Right. So these techniques are there. So does it mean that I will never select greedy technique? No. Right. So there are different kind of applications. Okay. There are applications where we want to use greedy kind of technique. Okay. There are applications wherein we want to use divide and conquer kind of technique. There are applications wherein we want to use dynamic programming kind of technique. Okay, so we must understand. Okay, so if an example is given to me, okay, so there are some problems, some standard problems for which we will know for solving this problem, for searching an element in the array, for example. So I will always use divide and conquer because that is the best technique. For example, okay, so now if any new problem is given to me, see, definitely the problems in computer science, the scope is very, very vast, right? We don't study everything, all the problems in our textbook. We don't study all the problems in our course. But then why do we learn this course? The idea is we will try to solve some standard problems. Okay, and we will know, okay, if the problem is of this kind, then greedy technique is best suitable for this kind of a problem. Okay, or let us say for such problem, divide and conquer technique is going to be the best. So that if I get a new kind of a problem that I have never discussed before, that I have never heard before, right? But can I map this problem into one of the problems that I already know? Right, and then that should my mind should be tuned. Okay, and my mind should be able to apply an algorithm. Okay, this kind of program design technique or algorithm design technique will be best suitable for this. Then there should be some proof, right? Because I know problem A could be solved by divide and conquer the best way. Okay, so I am able to, because I can map problem B to problem A, so I will solve problem B also using a particular technique. Okay, so that is what we are going to study now. Okay, so we will have some example problems wherein we will see that okay, if I solve this particular technique by this particular problem by all the three techniques, then based on the kind of problem this technique is the best. And now you know that when I say this technique is the best, in what terms, in what sense it is the best technique, right? That's what you do analysis of the algorithm, right? So how much time will it take to, when I write a program, how much time does it take to execute the program? How much memory the program is going to take, right? All those things are going to come under the analysis of algorithm. So you have already studied these two courses. Okay, definitely we are going to learn something new in this course. Okay, so we will see everything together, and we will try to compare them. All right, the idea is if I get to see a new problem, it should click. Okay, this is a problem which can I map this real life problem into one of the example problems that I have studied in my course. All right. So this is the textbook series. Maybe this you would have seen the textbook named as Data Structures by the same author, Goodrich MT. Okay. So this author has written, Goodrich has written books in data structures as well. Okay, and you will see the book by Goodrich MT of Java programming as well. So data structure books also comes with the programming. So you will see this. There are various books by the same author. We are going to follow this as the textbook, Algorithm Design and Applications. This book is available in soft copy also. It is available in internet, and I also have the soft copy. I will share it with you, but you can also download it. It's freely available. Okay, so this book is freely available, so we all can have a copy. And the reference book, this is the Corman by Corman. There is a reference book, Introduction to Algorithms. This is also a nice book wherein we have, various algorithms problems are there. Okay, and you will see, along with Corman, one of the author is Rivest RL. Okay, who is this person? So you must have studied RSA algorithm, right? RSA algorithm in cryptography. Okay, so he is one of the person of RSA algorithm. Hmm? So you must be knowing the why the name of RSA is RSA. And can anybody tell me? RSA. So there are three authors, Rivest, Shamir, and Edelman. By those three names, the name of the algorithm RSA. You must have heard, right? You must have studied also in your network security or in your cryptography somewhere RSA algorithm, right? Cryptography algorithm, very famous algorithm for encryption, RSA algorithm. Okay, so the same person is here writing this book along with Foreman. Okay, so that is Introduction to Algorithm. So that is another book that we are going to follow. So the other two text reference books, randomized algorithms and approximation algorithms, we may follow for one or two problems. Okay, so they are again very nice books, and they are also old books as well, 1995 and 2003. Okay, so I did not check whether these two books are available online or not. Okay, or else I think I have seen these, the chapters where if I want to find an algorithm, I can get it chapter wise also from these two books as well. Okay, so again I will say, have any doubt, students, if you get any doubt why I am spending time in telling you the textbook and reference book, in this course you get any doubt, please refer the textbook. Okay, don't start searching in Google. Okay, because if you search in Google, somewhere, Stack Overflow or somewhere you will go. Those links are helpful at times when you are doing programming or something, they quickly tell you the solution. But what exactly is the technique? Okay, because when you are talking of an algorithm, algorithm means, if let us say if I talk about RSA algorithm of cryptography, okay, then it's a standard algorithm that I cannot change. Right? I cannot change RSA algorithm. Yes, I can add something to RSA algorithm. I can add something to Huffman coding, but these standard algorithms we cannot change. Right? So if I say RSA algorithm and I want to find out, I must read the book. Okay. So for all the algorithms, if I say binary search algorithm or a specific Prim's algorithm or Kruskal's algorithm, if I say about those standard algorithms, please read the book for them. Okay, that's why I'm, specifying this part that this is your textbook. You get any doubt, please refer the textbook. You can definitely ask me, but further, if you have any doubt, we must have a practice of reading textbook. Okay, so before going to Google, please read it in the textbook. Search it in the textbook, because you will find that the best analysis, the best answer they would have given. Okay, you can trust the book. You must trust the book rather than initially trusting the Stack Overflow or something. Okay, so for this course, I would suggest you to read textbook. If you get any doubt, you must go and read the textbook, the algorithm from the textbook. Okay. This is what is the course objective, students. So these are the 5 course objectives, and we will try to meet all of the course objectives. Okay, so the first course objective is understanding various methodology for analyzing the algorithm. So we will mostly talk about the big O notation in this. Okay, various methodologies for analyzing this. So methodologies means, what are the various ways, we will start with, the primitive operations in the algorithm. So if you have a problem that, uh, find out the complexity of an algorithm, right? So there are some basic rules. We start with these are the primitive operations. Those will be used in the algorithm. Then you check, if there is a for loop of, then, based on the variable, how many number of times that for loop is executing. All those things those are the methodology for analyzing your algorithm. Okay, and then you have a master method also, right? So there are some rules, so that you have already studied. We will discuss them as well. Okay, so we will mostly talk about big O. We will also talk about big omega and theta as well. Okay, and then the next course objective is going to be apply different graph algorithms and analyze its complexity. Okay, so we will talk about the graph, the connected graph. We will also talk about the Prim's algorithm and Kruskal's algorithm. So all those kind of stuff we are going to discuss here in various graph algorithms, and we will analyze its complexity as well. Okay. Then as part of course objective 3, when we come to analyzing various algorithm design techniques, okay, and solve different problems using those techniques and analyze its complexity. So when we analyze various algorithm design techniques, as I told you, we will be basically talking about 3 techniques: greedy technique, divide and conquer, and the dynamic programming. Okay, so various standard problems, those are solved using these techniques. We are going to discuss about them. Okay, and then we will come to course objective 4, that is going to be evaluate the performance of various network flow algorithms. Okay, so the kind of problems, in real life, we see the problems, what should be, how the electricity should be divided. There is something, that you can, or let's say if there is a water line, so there is a limit, right? I cannot give water this much in a specific pipeline. So how much, what is going to be the maximum network flow? Those kind of problems we are going to solve in under course objective 4. Okay, and then finally we will talk about some standard NP complete problems. Okay, and we will also see the technique that comes under polynomial reduction technique. Okay, so again there are some standard algorithms, those we are going to discuss as part of course objective 5. Okay, so we will be able to do the complete thing because you already have a background. Okay, and this all is quite interesting. Okay, so it's all problem oriented, and then we will talk about, for the same problem there will be various techniques, right? So if then we will analyze that which technique is going to be the most suitable. All right. So this is going to be the evaluation pattern. There will be 3 quizzes. So our course is 50-50 basically, right? 50 internal and 50 external. So this we will keep it like that only, 50-50. Okay. So under 50-50, we are going to have 3 quizzes. The weightage is going to be total 20, 6.66, 6.66, and 6.68. So we will keep the maximum marks as 10, 10, and 10. And I will divide it equally in the course. After 1/3 of the course, we will have quiz 1. 2/3 of the course, we will have quiz 2. And last 1/3, we are going to have quiz 3. That's how I have planned. I will show you the plan. Okay, so 3 quizzes, because the idea of the quiz is once you do a quiz, you should be very quickly able to answer few questions from that. Okay, and then mid-semester is going to be 30 marks, weightage 30 marks. So as per the guidelines, there will be a written exam, only one mid-semester. So that will be of weightage 10 and the Viva will be of weightage 20 marks. Okay, and then we are going to have end semester exam again, that is for weightage 50. So therein your online exam, written exam will have a weightage of 20 and Viva is going to have a weightage of 30. Okay, so before we start with this, okay, I will quickly show you the plan that I have made. I will not read it line by line because you can understand that, you can analyze that. So for 2021, I have just changed the course plan. Here. So we will mostly not change this, only in the case, that we are not able to do what we have planned. Okay, generally we are able to do what we have planned. We will not change otherwise. Okay, so this is the lecture plan change. Okay, so we have, the course is divided into 3 units, unit 1, unit 2 and unit 3. So I have mentioned it, unit 1, right? So unit 1 subtopics are, these are the subtopics. You can just see, basically, we are talking about theoretical analysis, primitive operations, growth rates. We will basically talk about big O. I told you, right? Big O notation. And we will talk about various math preliminaries, and we will also see how to prove the bounds. Right? If you know the definition of big O, you have to find a C and you have to find an N0, right? F of N is less than or equal to C of Gn, right? Such that your C is a positive constant and N has to be greater than equal to N0, where C and N0 are going to be your positive constant, right? So how do you bound? That is what we are going to discuss as first unit topic, that is analysis of algorithm. So I have dedicated 2 lectures. I mean, this L1 may take 2 classes, but I just call it as lecture 1 like that. So L1 and L2 analysis of algorithm part 1 and part 2 we are going to cover as CO1. Okay, and then you have, again we continue with analysis of algorithm, wherein we talk about divide and conquer, recurrences, substitution method, recursion tree, master method, revision, and then we also do revision on sorting and revision on basic data structure. So this is just for namesake. I have written students revision of basic data structures. Definitely we will not discuss what is a stack, what is queue, what is linked list and all those things. I've just said revision of basic data structures. Probably we will just revise that. What is the complexity of creating a particular data structure? Okay, so here we have dedicated 4 lectures. Recurrence, I name it as recurrence part 1, recurrence part 2, linear sorting and basic data structure. Okay, so that's all. Still we are in unit 1 only, that is analysis of algorithm. Then you have application of graph algorithms, wherein we will talk about topological sort. Probably you had not studied this before. Okay, and then we talk about strongly connected components, bi-connected components, and your Prim's and Kruskers algorithm will be discussed here. All pair shortest path and single source shortest path algorithm. Okay, so we have 3 lectures here, graphs, shortest path, and we will talk about minimum spanning tree. Okay, and then in unit 2 we have applications of divide and conquer, greedy techniques and dynamic programming. Okay, so here we will talk about knapsack problem, scheduling algorithms, string matching algorithms, KMP, Rabin-Karp, and longest common substring. These are the algorithms. So this is the course plan as per your syllabus. Okay, so we will study greedy. So we have 3 lectures for greedy part 1, part 2, and part 3. Similarly, for dynamic programming, we have 3 lectures, dynamic programming part 1, part 2, and part 3. Okay, and then we have unit 3, that is flow network, right, wherein we talk about these algorithms. So basically, we will talk about application of maximum flow, bipartite matching. Okay, so we will talk about these algorithms also. And then we have flow network part 1 and flow application under unit 3. And finally, in unit 3, we have NP completeness, wherein we have various things. So there is no limit to it, how much we can do it. So based on how much time we will be left with, and otherwise we will take the standard problems here, important NP complete problems, and we will also talk about polynomial time reduction. And we will just have an overview of parallel algorithm. So approximation algorithm and parallel algorithms, I told you, right? So the two textbooks, those are in reference textbooks. So we will see something from them. Okay. So we have here, so these all are, those so many lectures are there, but they are very small slides. There are hardly 4 to 5 slides in each of the lecture. Okay, so this is as per the syllabus. We have the course plan. Okay, so now here we are seeing. So I am telling you. So this is what I wanted to say. So quiz one we will have it here. So how you have to understand the course plan is, it is like this. So quiz one will be this green color portion. See, it is made it here. No, you are able to see my screen, students, right?
Yes, ma'am.
Yeah. So this is what is the portion of quiz one. Okay, L1, L2, L3, and L4. Okay, so you must understand that, I may forget to announce in between that, this is the date for quiz. Definitely 1 week before I will say, but you must understand that after L4, a quiz is due. Okay, so L4 means it's not lecture 4, so this L1 may take 2 classes or 3 classes, L2 may take 2 to 3 classes. Okay, so like that, L3 may take, more classes, 4 to 5 classes like that. Okay, so quiz 1 is due after this L4 reference part 2. Okay, so the maximum marks will be 10, it will be through AUMS. Similarly, we will take for quiz 2 this portion. Okay, so quiz 2 is going to be L5, L6, L7, L8, and L9. So quiz 2 will have only this portion, not the previous portion. Okay, so starting from linear sorting till MS3 will be your quiz 2. Okay, and after quiz 2, this greedy and greedy technique, greedy part 1, 2, and 3, this will be covered, and this is the portion for your midterm exam. Till here, till greedy part 3, because midterm, I don't know when it will happen, but it will happen, after some time, So by then, that's what I plan to do. I plan to finish this greedy technique, greedy part 3. So that's what I have mentioned here. See, so midterm, if it says this much means the portion is starting from here till here. Okay, everything will be there in midterm. So online we will have maximum marks will be 25, weightage will be 10, and Viva maximum marks will be 20, and weightage is going to be again 20. Okay, because midterm exam we are going to conduct, the weightage for midterm is 30 marks. Right? So we will have online written exam, that is maximum marks will be 25. So it will be I will try to make it both objective as well as subjective. Okay, and you may not know. So what we will do during Viva is how you have attempted your exam. The same thing we will discuss in the Viva. Okay, so it will have your midterm will have the objective portion as well as subjective portion. Okay, and during Viva we will discuss that also, what you have done in the exam. Okay, so that is about the midterm. So after midterm, so we are planning, I am planning that greedy part 3 we will cover till midterm. Okay, and then after that we start dynamic programming after midterm. Okay, so I have planned that quiz 3 will be from this green portion again, the green colored portion. Dynamic programming part 1, part 2, part 3, flow networks part 1, and flow application. So L13, 14, 15, 16, 17, we will have quiz 3 from this portion. Okay, maximum marks will be 10 and weightage is going to be 6.68. Okay, and then, and finally, the guidelines for conducting end semester exam is that end semester exam is going to have 50% weightage, and we have got the guidelines that end semester exam should cover. It's 100% syllabus. Okay, but the 30% portion should be before, till mid semester, and 70% portion should be after whatever we cover after the mid-term exam. Okay, so accordingly we will have the paper for end semester exam. So that's why I have written here end semester. I have written 2 components. You will see here I have written 70% portion after mid-sem, because we are planning to have mid-sem till here. So starting from there till the end. Okay, so we are saying that this portion is 70% of end sem will be from here, and 30% of NSEM will be from here, unless until we get any new guidelines. So this is the plan. This plan I have made based on the guidelines that we have received recently. Okay, before your classes started, right, on 14th. So we 1 week back we received the guidelines for evaluation component guidelines for all orphans. Okay, so accordingly, this is the plan. If there is a change in the plan from university side, then only it will be changed. Okay, otherwise it is going to remain same. So that's what I have written here. End semester, this is the 30% portion. So here again, online we are going to have maximum marks at 35 because it will be a 1.5 hours exam. Okay, again it will be a combination of objective plus subjective, and the weightage is going to be 20 marks for end semester. Okay, and Viva will be, the weightage for Viva is 30 marks. So Viva maximum marks will be 30 and weightage is going to be 30. Okay, so I have properly thought about it, what will be the question paper, how it will be. Okay, and accordingly I have made this plan. Okay, hopefully we will be able to stick to the plan. Okay, so in this course, you know, if you miss a class, okay, because of placement reasons only, right? Otherwise, you will simply not miss the class. So you will be able to pick it up seeing the slides. Okay, so I have tried to put information in the slides. Okay, and of course the lectures are recorded as well. So only if you do not understand from your slides, then you can discuss with your friends, and then you can go through the recorded lectures. Okay, so if you are attending placement or something, we will continue with the classes, students, because we have only 3 classes per week. Okay, and we try to cover everything. Why? Because that is why you have opted for this course, right? So that we revise everything, right? So you know the importance of the subject. I need not tell you, right, how important it is from the placement perspective. So we will try to cover everything, and it is doable, students. Why I'm saying doable is because we did this last year, right? For your seniors also last year, yeah, they wrote one midsem. So there were 70 students in my class last year, and they wrote midsem, but the concept of Viva was not there that time. So I think I had given subjective questions only, and there were many questions. So because the exam was for 1 hour for the periodical test, okay. So yeah, it was like that. So but this time, you know, Viva is also included. So actually, including Viva helps you. You would have realized that, right? Because if there was something, you know, that you could not convey while writing your exam, you can convey that during your Viva, right? That is what is my understanding. So that's it, students. So we will stick to this plan, and we will be able to do it. So I have also written, you know, week wise how many weeks we will require, and we actually get those many number of classes. Okay, so that's it. So I will upload this plan into the team. Okay, so that all of you can see. That's it. Yeah, so let's get started now. Okay, so this was necessary, whatever introduction I had given, and yesterday I could not take your class, students, because what happened is at the same time I had C lab. So these people knew, you know, the timetable coordinators knew that they are making the timetable accordingly. But this is the last week for second semester students. So it was planned that, you know, I will take your class and I will join my C lab after your third hour. So the lab is there for 2 hours, third and fourth hours. But what happened is the other teachers who is there with me had some urgent meeting. So she could not attend that lab. So we had no other go than, you know, to cancel your class. But any time when all of you are free, okay, we can have that class. Okay, so you can tell me when in the group, you can tell me, you know, you all can plan that when we should have the class. So any afternoon when you are free, we can have that class. Okay, so not necessarily now, but whenever, you know, you people are free, or I will also see your timetable. So I can suggest you the time, and you can say that this time is fine, and then we can have the class. Okay. So because if we have all the classes regularly 3 hours per week, we will be able to do the portions easily, not an issue. Okay, so this is what, let's get started. Only 10 minutes remaining, but let's just do the starting of the course, right? So this is what is the picture, what this picture tries to say is, it tells you, it shows you that you write an algorithm. Why do you write an algorithm? You write an algorithm basically to solve a problem, right? Why do you write algorithm? You write an algorithm to solve a problem. So your algorithm becomes a step-by-step procedure for solving a problem. But something is very important in this definition, right? What is that important thing? The important is in a finite amount of time. So algorithm is a step-by-step procedure for solving a problem in a finite amount of time. I should not suggest you a solution, or I should not suggest you an algorithm which never completes, or which is not doable in finite amount of time. Right? It should not take unnecessarily lot of time. Right? So I should be able to do it in some measurable time. Okay, and the less time it takes, the more good it is. Right? Any problem, if you want to solve, someone can suggest you to solve. Someone can give an algorithm that solves it in 5 minutes. Someone can give an algorithm that solves it in 10 minutes. Someone can give an algorithm that solves it in 1 day. Obviously, we are going to pick the solution that gives me 5 minutes. Okay, so you must understand, the various cryptography algorithm. When you say that, this algorithm is very much secure. What is the meaning of that? Suppose I say algorithm is very much secure. Okay, it doesn't mean that it cannot be cracked. Okay, it doesn't mean that it cannot be cracked. Or you want to hack a password. Okay, you want to use so some password is secured using an algorithm. Okay, it doesn't mean that nobody can break that password. You cannot get what exactly is the password. You can get the password, but in some amount of time that is too high. Okay, if you are able to break a password in 2 days time or 3 days time, right, that's how you say that the algorithm is secure. So if I am able to break the algorithm, I want a password immediately in 1 minute, or at the max 2 minutes. Okay, so if I am not able to crack the password, if I'm not able to crack the password in finite amount of time, not only finite, very less amount of time, so I say my algorithm is very much secure. Okay, so algorithms are written, definitely algorithms take some input. Okay, and the input is processed by the algorithm to give you some output, right? So and corresponding to the algorithm, we can always write a program, right? So what exactly we mean by the running time of an algorithm? Okay, so most algorithms transform input objects into your output objects. Okay, so the running time of an algorithm typically grows with the input size. Okay, so if you have an algorithm, right, that is going to process some input, you keep on increasing the input size. Okay, what happens is the algorithm takes more time to process those many number of inputs. Okay, so here what we are showing is this yellow color is the best case, and this blue color is the worst case, and this green color is the average case. So you will see that if you just compare this best, so increasing with increasing input size, the best case time also increases. With increasing input size, the average case time also increases. With increasing input size, the worst case time also increases. Okay, so this is the running time. Okay, so what typically we do if an algorithm is given to me, so we actually measure, how complex the algorithm or what is the growth rate of the algorithm by its worst case time. We always assume the worst case scenario to compare two algorithms. Okay, because the best case time, we generally ignore. Okay, we do not compare algorithms based on the best case time. Okay, we compare algorithms only based on the worst case time, and finding out the average case is little difficult. Finding out the average case time is little difficult because average is like you have to run some number of cases and then take an average of it. It is very difficult to determine, basically, average case time. Okay, so we focus on the worst case running time of algorithm because it is easier to analyze. Okay, and worst case time is important. That is crucial to applications such as your gaming applications, your finance application, or your robotics application. We always assume the worst case scenario, and then we try to make our policy. Then we try to select the algorithm. All right. So this is, so wherever I have written here, this is the textbook reference. Okay. So 1.1 means from the textbook section 1.1. This has been taken. Okay. Then we have done, through the experimental studies, this has been found, for example. Okay. So here what we are showing that the input size is growing like this, 0, 50, 100, and time in milliseconds is growing like this. Okay, now how exactly we do using experimental study? Okay, experimental study means you have written, so you have two algorithms. Okay, so you have algorithm A and algorithm B, and you want to compare those two algorithms. So what you do is you write a program that implements your algorithm A, you write another program that implements your algorithm B. Okay, so now you have two programs, and then you actually give the input to both the programs. Okay, and then you see how much time both the programs are taking for the same input. Okay, what I'm saying is you want to compare between two algorithms, algorithm A and algorithm B. So what you do is you write a program corresponding to algorithm A, and you also write a program corresponding to algorithm B. Okay, and then you give the same input. Both the algorithms are for the same thing. They are trying to solve the same problem, let us say. Okay, and then you give input to program A and also give input to program B, and actually see how much time do program A takes and program B takes. Okay, and now when you want to compare only one program, how the program behaves or how the algorithm behaves based on the increasing input size. So what you do is you write a program that implements your algorithm, and then you run the program with inputs of varying size and composition. You give different inputs, different input size, and actually you run the program. And then you see that how much time did it take. Okay, so to see, how much time did your program take? How you can measure the time? You can write a function call. So this is a function call that is there in Java. System.current time millis. Okay, so what it does is it actually gives you times in milliseconds. Okay, so this in Java you can give a method like this, system.current time in millis. If you give like this, it gives you, and you see if you try to print it system.out.println in Java, it will give you the current time in milliseconds. Okay, what is the meaning of current time in milliseconds? There is a reference time. Okay, from that time, how much time it has passed. So it will give you the current time in milliseconds. So a big number it is going to give you. Now, if you want to check that how much time your program has taken, what you will do at the starting of the program, just before the main loop, okay, or if you have written a function, just before calling the function, you are going to print this. And just after when the function returns, you are again going to print the time. Okay, so this function call is going to give you a current time. So you need to subtract it to find out how much time actually your function has taken, or how much time actually your algorithm has taken. Right? So to tell you that if you change the input size, the program takes different amount of time. So this is an experimental study that has been seen. Okay, that generally, if I'm changing my input size, if I'm increasing my input size, the system time, the time it takes keeps on increasing. Okay, now we are not saying that it increases linearly, or it increases in quadratic fashion, or it increases in cubic fashion, or it increases in a log scale. We are not saying that. We are just saying that with the increasing input size, the time taken also increases. That's what we are saying. Okay, so we'll continue with this, students, in the next class. Okay, because there are some very important questions that I want to ask you. That should I always do like this? I want to check. Let me ask you that question now itself. Okay, if I want to check what is the performance of my program, Should I always do like this? I convert it to a program and then actually run it and then apply something like this to find out how much time has it taken? Should I always do like this?
No, ma'am.
We should not do like this, right? Yes. That's why we are studying algorithm analysis, right? Without converting it to program, we should be able to find out that approximately how much time it is going to take, right? Okay, so we'll continue with this, students. Tomorrow, in tomorrow's class, we'll continue with this. All right. Thank you, students.
Thank you, ma'am.
Thank you, students. Yes.
Thank you, ma'am.
Yeah. Thank you.